Hello all. In the last few sessions we were discussing about what sentence classification is in NLP and how do we perform sentence classification using RNN, LSTMs and GRUs. Along with that we have also seen performance metric for sentence classification. Today in this session I would like to talk about sequential labeling. Okay, so we will see what sequential labeling is and how do we do sequential labeling in context of NLP. Okay, so when we have talked about sentence classification task, the major aim of sentence classification is to assign some label to a given sentence. For example, we have seen email filtering, right? So when in the context of email filtering, email is the input sentence that I give, and based on this input sentence we give a label whether the email is a spam or not a spam, right? So although in real world applications we use sentence classification in many of the cases, but along with this we also have to discuss about how to assign labels to so many words in the given sentence. Okay, so when I talk about labeling the words in the given sentence, it is all about your sequential labeling. Okay, now when we talk about sequential labeling, the first thing that comes into picture, what if I want to assign meaning to individual words but not the entire sentence. Okay, when I talk about sentence classification, the entire sentence is given some label, but here not the entire sentence, but I want some words in the sentences to be labeled. That is, I may have n number of labels in the given input sentence, that is multiple input and multiple outputs. Okay, so the most typical scenario you want to encounter is you want to extract something from the sentence which cannot be easily solved by sentence classification. Now this is where our sequential labeling comes into play. Okay, so there are two cases that you can see here. The first one is sentence classification, where I take an input sentence which have n words and I am giving only one label to that particular sentence. Whereas in case of sequential labeling, I take the same input sentence with n number of words and for each word I generate a label. Okay, so basically sequential labeling is an NLP task where given a sequence such as any input sentence, the NLP model will assign a label to few words or all the words in the given input. Okay, so here not just one label, but for every word or most of the words the labeling will be given in sequential labeling task. Okay, so I would like to discuss about two important sequential labeling tasks. Okay, the first one, when we talk about it, let's take case 1. Okay, so the case 1 we are going to discuss about POS tagging, parts of speech tagging. We know how important parts of speech tagging is, POS, parts of speech, is in the context of learning any language, right? So when we talk about the first scenario, when do we need a label per word? Okay, so the first case is sequential labeling comes in handy when you want to analyze the sentence and produce some linguistic information from word. Okay, what is the importance of each and every word in that given sentence? Okay, so to analyze the meaning of that particular sentence or word in the given sentence, we use POS tagging. Okay, so POS tagging produces what? POS tags for each and every word. Okay, as you can see here, the given sentence is time flies like an arrow. Okay, so time and arrow are noun, an is a determinant. Okay, flies is a verb. Okay, so each and every word will have a POS tag attached to that. Okay, so this is case 1. And when we talk about case 2, okay, the second case is NER, name entity recognition. When I give an input sentence, okay, the name entities in each and every word should be identified and recognized and specified. Okay, so another scenario is when you want to extract some pieces of information from a sentence. Okay, for this example we take NER, which is a task to identify or mention some real world entities. Okay, as you can see in the sentence here, Apple is looking to buy UK startup for $1 billion. Okay, so when you talk about this, if we don't read the entire sentence, apple would be taken as a fruit. Okay, but here with context of all other words related to this particular word, Apple is recognized as organization. Okay, so when you talk about UK, it is a geographical location. Okay, when I talk about $1, it is money. When I talk about billion, it is money. So not all but few entities would be recognized and they would be named. This is called as name entity recognition. So the two important sequential labeling tasks are POS tagging and name entity recognition. Okay. Now, how do we implement POS tagging? Obviously, we will be using RNNs. Okay. So, let's see how do we use RNN to encode sequences. Okay. So, already we have seen sentence classification, right? How do we use RNN to convert an input of a variable length to a fixed length vector, and how do we assign scores, right? So, we have defined a function RNN vector. We give the initial state and update the state with the state and current word and return back to the state, right? So, this is the simple RNN code for encoding the sequences in sentence classification task. Now, how do I design that RNN for sequential labeling? Okay, so when I talk about the RNN architecture here, so here for sentence classification we had John loves Mary was a sentence, and based on these words I had only one state. Okay, so we have to modify this structure because for each and every input word I want my output to be produced. Okay, I don't want my output at the end, but I want my output to be produced for each and every individual word in sequential labeling. So we change or we modify the architecture or code, as in you can see define RNN sequence of words. We define the initial state. For word in words I update that and I append the state to the state. Okay, so I append that word to the existing state so that I will get to my output of the corresponding word. Okay, now if we apply the function to the time flies example, that is write it without using a loop. Okay, I don't want, here I am using a loop for word in words. If you don't want to use this loop and write it, so we will write state v of time flies like an arrow. For each and every word I am appending a state such that the POS tagging of each and every word would be generated. This is without loop and this is with loop. So this is how we define an RNN function for implementing our sequential labeling task. When you look at the architecture here, as you can see, I am not taking the state as output at the final stage. Okay, here for every word I am generating the state with respect to the update function. Okay, so for each input word the network produces the corresponding state that captures the information about that word instead of one state at the end like we have done in sentence classification. Okay, so this is the RNN architecture on how do I use RNNs for sequential labeling task. Okay, now if we think of RNN as a black box, okay, if we think RNN as a simple black box, it takes sequence of something, okay, some words or word embeddings in short. As we can see, vector representation of time flies like, you can extend the sentence and take it. Okay, now this converts the word into sequence of vectors that will encode some information about individual words. Okay, so individual words are being generated, and for that you can add a linear layer where you can produce your chits, that is individual POS, that is noun, verb, adjective, preposition, pronoun and all that stuff. Okay, so this is all about how do we use RNN for sequential labeling task. Thank you so much.